Hey, so welcome back, and this is another daily LeetCode problem. So today's March 30th, and the deadline for today's problem just passed, so I hope you did a good job with it. But yes, let's take a peek at what today's question was. So it was called Scramble String, and I don't want to give the answer just yet. And so it's actually a dynamic programming problem, and I'll be giving you a top-down like memoization solution for it. And so what you're given is two strings here, S1 and S2, and we're going to scramble, say S1 in this case, and we want to see if we're following this particular kind of scrambling pseudocode. You want to see if you can formulate S2 to see if S1 is like could be a scrambled version of S2. Okay, and so the logic here is recursive logic, and they're very explicit about it. And that's why it was very natural to come up with like a top-down memoization solution. And so first case is you want to say, okay, if the length of the strings are 1, then just stop there and return true. Okay? And so then following that, okay, well, if the lengths are greater than 1, then we're going to just follow these 3 steps here. And so we want to divide it at some random index. So it could be between 1 and the length of the string kind of -1, because we need at least these two substrings that we're splitting in half, or not in half, but splitting into 2 parts to have a length of greater than 0. And so they have to have at least 1 character in it. And so the second part is we can either, 2 options here, we can either swap the 2 substrings that we just kind of split at a random index, or we can keep them in the same place. And so from there, you're just going to kind of keep recursively performing this call until they have a length of 1. Okay, and so let's go ahead and implement this. So we're going to return the result after calling our DP function that we're going to implement. And so we're just passing the 2 strings that's given to us. So let's define our function with S1 and S2 again. And so we're going to want to cache this result. So this is going to take up a little extra space, but it's going to give us that performance benefit in terms of time. So it'll reduce our time complexity. Plus on LeetCode, you get like a TLE or like run out of time if you don't do this. So, and for the solution to work, you have to do it. And so from there, what we're going to do is, okay, we're going to return true if these 2 strings match, because then we know that yes, they are in fact able to be scrambled such a way that they equal each other. And so if that's the case, then let's return true immediately. We don't have to do any more work. This is our base case. And so from there, what we want to do is, if none of these paths work, there's kind of 4 paths or more than 4 paths. There's several paths that you can go down, either by you split out a particular index and then you keep them in the same and then you don't swap them, or you split them out a particular index and swap them. And so this path, these 2 paths that you can go down, kind of recursively happens, and you can go down, either way at each iteration. And so from there, what we want to do is say, okay, where can we split at? Well, we can split at between I from 1 to the length of the string of S1. So I from 1 to, so I didn't type this out enough, in range from 1 to the length of the string. So this is all the places where we can make that kind of partition at. And then we say, okay, well, what if we split from this string and we don't swap the ordering? Then, well, we say, okay, if S1 from I onwards, so you split at this particular index, and we want to compare then the first chunk on the left-hand side. And so what that would be is this, and we compare it with S2. So we haven't swapped the order, and we would just want to compare the first chunk that they equal each other. And so then we're also going to want to do the same thing but for the opposite side of this chunk. So all the way up to that particular index that we're splitting at. And this is the case, then we want to return true. And then finally, we also want to check the opposite of this case where, well, what if we do actually swap at this particular index? And so from there, you do -I. And so this is kind of saying, okay, where we compare everything from I onwards, so like from 2 onwards, and then we compare the swap from like everything up to 2. Okay, so let's take a peek at that. And so same thing here, we want to reverse this logic. Great. Sometimes I type it out wrong. Yeah, and that's today's daily LeetCode problem. So I totally get where it's kind of a hard problem because, well, there's a bit more logic to this question, like the explanation isn't quite straightforward. There isn't much code that you have to write behind it, but it is like a dynamic programming solution, and you do actually have to add some memoization in order for it to pass. And so this just recursive relationship is quite complicated, but when you write out the code, it's very, very simple. Like having to read a developer's code that wrote this, like I think it's very understandable. It's more for me was understanding the relationship of adding this -I here and comparing it with the other half when you're performing this case where like hashtag is swapping the ordering. That took a bit of effort, and you kind of have to draw it out, that, you know, the slicing that you're doing on these arrays. But yeah, so this is today's daily LeetCode problem, and I hope it went well for you. So have a great day. Thanks for watching.